The engine is not self-starting, so external power is required to crank it by rotating its crankshaft. In this video, we are going to learn about the starter motor, which is used to crank the engine. First of all, let's look at an outline of starter motor operation. The engine has a flywheel. The circumference of the flywheel is toothed, creating a ring gear. The pinion gear mounted to the starter motor meshes with the ring gear to turn the engine crankshaft, inducing the initial combustion. Let's look at the actual operation. There are three types of starter motor. This is a reduction-type starter motor whose operation we have just observed. This is a planetary type. And this is a conventional type. Now, let's look at the construction, operation, and inspection procedures for the conventional starter motor. The starter motor can be roughly divided into three mechanisms. An electric motor that generates torque, a transmission system that transmits the torque to the engine, and a magnetic switch that pushes the pinion gear so that it meshes with the ring gear while transmitting electricity to the electric motor. Now, let's look at the electric motor that generates torque. The outside yoke of the electric motor is made of steel and cylindrically shaped. Inside the yoke are field coils, made by winding coils around pole cores bolted to the yoke. The field coils are made of thick lead wire to handle strong electrical current. The field coils generate the magnetic field required to rotate the armature. One of the armature components is an armature core, which is grooved so that the armature coils can be wrapped around the armature core along the grooves. Both ends of each coil are connected to the commutator. The torque generated at each coil is combined to rotate the armature, that is, the armature shaft. This is the brush holder on the commutator side of the armature. Let's take a look at the brush holder from the commutator side. The brush holder holds 4 brushes which are pressed against the commutator. Of the 4 brushes, 2 are supported by the insulated holders and are connected to the armature coils and field coils via the commutator. The other 2 brushes are grounded to the body. Next, we'll look at the starter motor transmission system. The transmission system transmits the torque generated by the electric motor to the flywheel. A pinion gear is mounted on the end of the armature shaft of the electric motor. When the magnetic switch is activated, the drive lever pushes the pinion gear to this position. At this point, the pinion gear meshes with the ring gear to crank the engine. When the engine starts, the starter clutch is activated, idling the pinion gear. Then, when the starter switch is turned off, the pinion gear is immediately disengaged from the ring gear. Let's look at the actual mechanism. The starter clutch is a one-way clutch combined with the pinion gear. There are screw splines inside the starter clutch. There are screw splines on the armature shaft as well, so that the pinion gear can move along the splines while rotating. The screw splines help the pinion and ring gears mesh smoothly. When the pinion and ring gears mesh, the engine is cranked. While the pinion gear is rotating the ring gear, the starter clutch is engaged. Once the engine has started, the pinion gear is rotated by the engine via the ring gear. The starter clutch is then released so that the pinion gear idles, preventing starter motor overrun. Let's move on to the third mechanism, namely the magnetic switch. The magnetic switch activates the drive lever to push the pinion gear, then leads electrical current to the motor circuit. This is a simplified illustration of the magnetic switch mechanism. There is a plunger at the center of the magnetic switch. The plunger has two functions: to activate the drive lever, which is attached to one end of the plunger, and to directly connect the main contacts via the contact plate attached to the other end of the plunger. The plunger is wrapped with a pull-in coil, which pulls the plunger to the main contacts. A hold-in coil is wrapped over the pull-in coil so that the plunger remains pulled. When the starter switch is turned on, electrical current flows to the pull-in and hold-in coils to generate magnetic fields. The magnetic fields then pull the plunger toward the right. This causes the contact plate to connect the main contacts. At this point, terminal 30, supplied with voltage by the battery, is directly connected to terminal C, which is connected to the motor. This allows strong current to flow to the starter motor. At the same time, the pinion gear is pushed via the drive lever to crank the engine with strong force. What is the construction of an actual magnetic switch? As you can see here, the pull-in and hold-in coils are fixed in the switch housing. The contact plate is located on the coil side with the main contacts on the opposite side. Let's also take a look at the magnetic switch with the housing disassembled. The pull-in and hold-in coils are wrapped around the plunger, which has a return spring like this. This spring returns the pinion gear to its original position after the engine starts.